Compared to block and file storage, object storage is the new kid on the block, and while it's got its traditional data center, it's a really good fit for cloud storage requirements. And if we want to give ourselves a frame of reference to compare object storage maybe to block or file storage, we'd have to say it's a lot more similar to file storage than it is to block. Objects themselves are more like files than they are blocks. In fact, you could probably say that objects are files. They're just a bit like files on steroids. And with objects, it's all about the metadata. Objects have extensive metadata associated with them. Now, metadata, by that we mean the data that describes the object. Now, some traditional examples of metadata include things like file type, the date the file was created, last modified time, file owner, file group owner. Basically, any attributes that are associated with the file, but not necessarily fundamental to the content of the file. For example, a movie file has got all of the metadata that we just mentioned. File type, creation time, modification time, owner. It's got the lot, but you don't care about any of that while you're watching the movie. Now then, while objects have all of that kind of metadata, they also have a boatload more of custom metadata. So you as an administrator or a user can define and customize metadata to your heart's content. And this has got some great use cases, not least of which is in the medical space. Medical images like MRI scan images or X-ray images can be bundled with extensive metadata about the patient, about the image, about the scan. We could have the patient's medical history as metadata, background to the image, for example, why it was taken, the name of the patient, the date it was taken, current health of the patient, hospital the image was taken at, the physician that's responsible, any users who have viewed the file, when the file has to be deleted from records. Basically, the metadata that we can associate with objects can be whatever we want it to be. We can customize and define until the sun goes down. This metadata is then indexed on the object storage device and could be searched against for data mining and other kinds of research. Now then, another hallmark of object storage is the extensive use of APIs. While some object storage devices have traditional NAS-type interfaces so that they can be mounted and accessed via protocols like NFS and SMB CIFS, not all object storage devices do. However, they all do support API access via APIs such as REST, SOAP, and XAM or XAM. Object storage devices also have massive flat namespaces. But what do we mean by a flat namespace? Let's take a look at a traditional hierarchical file system namespace. Traditional file systems are hierarchical and they resemble an upside down tree. We've got one on the slide as an example. Files are stored in directories or folders which are nested within each other and can often result in complex tree structures that are hard to navigate and extremely hard to manage permissions on. They just don't scale well. In comparison, object storage systems are based on a large flat namespace and they don't employ a hierarchical tree structure to store their objects. True, the flat namespace can be sliced and diced into containers or buckets for security purposes, but they can't be nested within each other. And while a massive flat namespace like this might make life hard for a human being when it comes to finding and organizing objects, it's fine for a computer system because they work with metadata and they don't need hierarchical file systems to be organized. So object storage was absolutely defined with massive scale in mind, cloud scale if you will. However, on the performance front, object storage is never going to be a world beater. In most cases, object storage devices support low performance, particularly on the random write front, though they can give decent streaming sequential performance. Object storage is also best suited for datasets that change very infrequently, things like video files, images and audio files. The reason for this is because object storage doesn't allow updates in place. Basically, if you want to change just a tiny part of an object, you end up creating an entirely new object in the process. Now all of this makes object storage ideal for cloud scale and ideal for cloud use cases. your typical social media use cases that are big on uploading family photos and videos from the latest family holiday and other things like that. Large files that tend not to change and don't require blistering performance, but sometimes could do well with good streaming performance. Now on the availability front, object storage usually works with node level redundancy. This is where you can lose an entire node in a system, and by a node we mean the combined compute, RAM and storage, and not lose access to your data. It's common to be able to choose your level of protection and availability as well, such as how many copies of an object you want, 2 copies, 3 copies, maybe 4 copies. But in order to keep 3 or 4 copies of your data, you would need at least 3 or 4 nodes in your system. If you want to maintain that node level availability, there's no point having 3 copies on the same node, because if you lose that node, you've lost your object. Now then, if you have enough nodes in enough locations, each copy of an object can be stored in separate discrete data centers or even geographic locations. This means that losing a data center, or even all of your data centers in a city or maybe a country, that won't affect your access to your data. Again, this is cloud scale, and the likes of Amazon S3, Microsoft Azure, Rackspace Cloud Files, they're all architected like this. Now last but not least, security. Now security is vital with object storage, especially if you're going to be hosting your objects with third parties over the internet, the likes of Amazon, Microsoft and Rackspace. Your data is hosted by a third party in a third party's facilities on third party kit, so if it's in any way sensitive to you, even your family photographs, you'll want to encrypt it. Now aside from encryption, object storage devices, including these third-party solutions hosted on the internet, support authentication, where you validate your identity via a username and password, and once you're authenticated on the system, you can then create and delete objects and containers to your heart's content. Now as we've mentioned, some examples of third-party internet-based object storage services include Amazon S3, Microsoft Azure, Rackspace Cloud Files. There's loads more. However, they all tend to work as follows. You create an account and provide your credit card details. They then take some money off you and you can upload your data. Now if you've got a lot of data to upload, you can normally seed your data, sometimes called a bulk upload. This works by you copying your data to one or more USB hard drives and then mailing them to your cloud storage provider. Once your provider receives the drives, it checks them for viruses and things like that, then it uploads them to their cloud storage system. From this point on, you pay for what you use, and you access your data via APIs and web browsers, and can often manage and report on your data either via provided control panel or again via the supported APIs. Now then, because all data in these scenarios is accessed over the internet, access can be slow. And to get around this, some cloud storage providers partner with providers of content delivery networks, or CDNs. CDNs are where farms of servers are strategically placed around the globe and cache data locally to provide you a far better performance experience. For example, if your cloud provider has data centers in the US and the UK, but you want fast access to your data in Australia, that access will be pretty slow, unless your cloud provider partners with a content delivery network provider that has servers in the Australia region. They can then cache your data on their servers in Australia, and when you're in Australia, you can get that faster performance. And you know what? I think that's about everything on IP storage. Now let's do a lesson summary.